Imagine a cosmic feast where a supermassive black hole gorges on gas, but only a tiny fraction actually gets swallowed. The rest is spewed back out into space. Sounds inefficient, right? Yet, this is exactly what's happening at the heart of the Circinus galaxy, where an international team of researchers, led by Wout Gozart of Leiden University, has uncovered a fascinating feeding mechanism. But here's where it gets even more intriguing. This black hole isn't dining alone. It's being served by two spiral arms that funnel gas toward its gaping maw. And this is the part most people miss. Only about 12% of the incoming material actually vanishes into the black hole, while the rest is ejected before it even gets close. Using the ALMA observatory in Chile, Gozart and his team peered into the Circinus galaxy, a mere 13 million light-years away in the southern constellation of Circinus, Latin for a pair of compasses. Despite its proximity, this galaxy remained hidden behind the Milky Way's disk until its discovery in 1977. By combining ALMA's observations with advanced models, the researchers identified the two spiral arms swirling around the central black hole, acting as cosmic conveyor belts for gas. Their findings are set to be published in Astronomy Astrophysics, with a preprint already available on arXiv, https://arXiv/abs/2510-05199. But here's the controversial part. While black holes are often depicted in pop culture as voracious vacuum cleaners, the reality is far messier. Gozart explains. In cartoons, you see a gas disk spiraling into a black hole like a whirlpool. But without a supply channel, that disk would just keep spinning indefinitely. These spiral arms, he argues, are the crucial passageways that make the feeding process possible. However, not everyone agrees on how this mechanism works, and some researchers question whether all supermassive black holes rely on similar structures. The discovery didn't come without challenges. As Gozart began his research, another team published a paper on the same data and black hole, raising concerns of redundancy. We were worried, admits Violet Impellizzeri, Gozart's master's thesis supervisor at Astron, the Netherlands Institute for Radio Astronomy. But we decided to dig deeper, and that's when we uncovered the spiral arms. Their persistence paid off, as they also calculated that gas in these arms moves inward at staggering speeds of up to 150,000 kilometers per hour. This raises more questions than answers. Why does so little matter actually reach the black hole? Are these spiral arms a universal feature of supermassive black holes? And what happens to the ejected material? Does it fall back into the black hole like a cosmic fountain? Or does it drift away to form new stars? The researchers are now turning to tools like the Event Horizon Telescope and the upcoming ELT in Chile to find out. Here's where you come in. Do you think these spiral arms are a common feature of black hole feeding? Or is this a unique case? And what do you think happens to the ejected material? Recycled or lost forever? Let's spark a discussion in the comments.